set of exercises in this video tutorial will demonstrate how to use the consensus viewer to identify conserved non-protein structural elements in a set of homologous proteins, which in this case will be waters. So let's begin by choosing Tools, Protein Preparation. This will open the Protein Preparation Wizard panel. So now let's enter 2PCY and then click Import. Now 2PCY is imported into the project and displayed on the workspace. Next, we'll deselect Delete waters beyond n angstroms from het groups, and that's because we'll need all waters for this exercise. Then click Pre-Process. Now let's choose Tools, Protein Consensus Viewer, and then click Import and choose From Workspace. So now the structure in the workspace has been imported into the sequence viewer in the panel. Next, click Find and Align Homologs. This opens the BLAST search settings. Now from the database option menu, choose NCBI PDB, non-redundant. Now if you have a local copy of BLAST, then choose local, otherwise you can choose remote to use the NCBI server. Then click Start Job. When the job finishes and the BLAST search results dialog box opens, you'll notice that the top 10 results are pre-selected in the table. We'll go ahead and incorporate this selection, so click Incorporate Selected Rows. This will download the 10 homologs and add them to the sequence viewer. Now in the water section, we'll choose Consensus from the display option. So here the consensus water structures are displayed with the proteins in the workspace represented as spheres and outlined. In this case, there is only a couple of consensus water structures highlighted here and over here. And that's because consensus is defined as having a water at this position in at least 60% of the structures. So we can change the percentage under Defined Consensus to say 50 and then hit Enter. Now more consensus water structures are shown at several locations. Notice that at some locations the spread of the position of the waters is greater than at others. Also notice that some spheres have hydrogens in white while others do not. This is just because the hydrogen atoms are present on the waters in the prepared 2PCY structure, but not present in the other structures. Okay, in the All row of the toggle table, choose A, remove everything from Workspace. Then, back in the Consensus Visualization panel, click the checkbox for 2PCY_A in the Sequence Viewer. Then, click the checkbox for 1JXG_A in the Sequence Viewer. Now, the 1JXG protein is displayed with the consensus waters along with 2PCY. Notice the 1JXG spheres overlap with the waters for 2PCY at 5 of the 6 water locations. Finally, at any time you can ascertain the identity of a conserved water by moving the cursor over the consensus water and viewing the text in the status bar below the workspace.